It was the early 1800s. The city of London was bustling with carriages. The evening London was lit up with gas lamps. It was the beginning of modern scientific era. Scientists were rock stars back then. Amidst all this, in the suburbs of London, a very special boy, an extraordinary boy, was born in a very ordinary family to a father who was a blacksmith struggling to provide sustenance to his family. The boy was very curious and bright, but unfortunately he had to drop school at the age of 13 or 14 and join a bookbinding shop as an apprentice. Usually this is the end of the story. This is it. You don't get anywhere from there. But for this boy, this bookbinding shop was a portal to a whole new universe. A universe of knowledge, of science. So throughout the day, he will help binding books, but in the evening and throughout the night, he will be voraciously consuming the knowledge contained in those books. The physics, the astronomy, chemistry. He was fascinated by all this. It was around 1803. Humphrey Davy was the hot topic of London back then. His lectures at royal institutions ignited very young minds as well as the common people of London, especially his work with the laughing gas and electrochemistry. Also Thomas Young. You know about the Young's double slit experiment, right? That proves that the light was really wave. It was wave. I'm coming to that story. It's interesting. It's intertwined all these things together. So this very curious boy, he was spending his time consuming all the knowledge in the books that he was binding. People noticed. A very kind customer noticed it and realized the potential of this boy and gave him a ticket to a series of lectures by Sir Humphrey Davy. That was the pivotal point. This not only did change the life of that boy, but it changed the world that we know. So this teenager boy started attending the lectures of Sir Humphrey Davy. He started to take notes. He not only took notes, he worked on them, elaborated them, drew diagrams, and compiled this whole series of lectures into a beautiful book. And one fine evening, he actually gathered all the courage, wrapped the book in a gift pack, and wrote a letter with his shaky hand to Sir Humphrey Davy, asking for a position of an assistant in his lab. This was a daring move. You can imagine the class system back then in London. He is from a blacksmith family, lower in the hierarchy of class system. But, to everyone's surprise, Humphrey Davy actually gave him the position. He was impressed by the curiosity, this hunger for knowledge. He gave him the chance. It was something like the bearer position in our colleges these days. It's like fetching this instrument for him, setting up the table for the experiment, this kind of stuff. But this gave him the window of opportunity. In the absence of his master, he was performing his own studies and experiments, which led to discoveries. And he started presenting his work. People started to notice. Faraday came to prominence pretty quickly with the electromagnetism. He is one of the most influential scientists in all history, but he was the most influential person in electromagnetism. Towards the end, he suggested something profound. So before that, coming back to the boy was none other than Michael Faraday we're talking about. So it was the time when Faraday joined the Royal Institution, 1803, around that time. Thomas Young presented his work with the interference of light, and he showed with his double slit experiment, demonstrated in front of audience in Royal Institutions, that light was a wave. Coming back to Faraday towards the end, when he was a prominent scientist, he proposed that light, this light that comes out of, fire or sun, the same light that we're illuminated right now, is kind of oscillation of the electric and magnetic lines of forces. This was a radical idea, unacceptable idea, to be honest. How come this fire lamp has anything to do with electric charges or magnets? So Faraday was ridiculed, laughed at. He almost lost his reputation. But here comes the next generation of scientists. James Clerk Maxwell, a young mathematician and physicist who was strong in mathematics. So Faraday was amazing with his ideas, intuition, and experimental ability, but he was lacking the mathematical strength. So he couldn't support his theory of light as an electromagnetic wave. So Maxwell came along, was an admirer of Michael Faraday. He took his master's ideas seriously, worked on them mathematically, and proved that indeed light was an oscillation of electric and magnetic fields. Anyway, in this lecture today, we are going to prove that. From the equations of electromagnetic theory, we're going to prove that light indeed is a wave, an oscillation of electric and magnetic field. And I hope you enjoy. So let's go.